Hello, everyone. Nice to see you. Hi, Matt. I'm
Hey,
Lena, head of AWS Developer Relations in North America. And we have here Matt, Vice President for Business Analytics at AWS. But actually, today we'll be chatting with Matt as just two data nerds, two data and analytics technologists. So the chat can feel free to ask any questions, me and Matt. Sometimes it's just nice to step away from products and services and have a fun chat on what is happening in the world of data and analytics to reflect on the progress of what's been happening in the ecosystem and exchange some thoughts on that. So first of all, I want to ask you and our audience in the chat, how did you find yourself in the space of data and analytics, and what got you interested in that area in the first place?
Number one, thank you for inviting me here, Lena. You and I didn't get the Hawaiian shirt memo. I don't know what's going on there. We have to do a correction of error on our messaging on this one. We were both wearing black. But yeah, I've been working in the data space for quite a while now. It was, I think, as most folks will tell you, I don't think my story is that unusual. It's kind of the product of necessity. I was working on the Human Genome Project back in the UK. On the tail end of that, we were doing a lot of work around visualizing the genome. We were doing sequencing of various different species. So we were working on human. We were doing zebrafish. We were doing gorilla. 40 different species to see what we could find, and looking at comparisons between the different species. And when we were working on the original sequencing for the human genome, our data coordination was in the order of gigabytes, right? The whole human genome is about 3 gig. And if you combine a whole bunch of other information around it, you can get it up to about 30 gig. But there were 3 different sites globally working on the human genome, one in Cambridge in the UK, where I was based, one in Japan, and one here on the east coast of the US. And we used an iPod for data coordination. We just loaded the build onto the iPod and physically shipped the thing using FedEx to the next coordination site. They would load their data on, and this thing went round and round the world. It's in, I think it's in one of the museums in London, this little iPod that we used. You should never underestimate the bandwidth of an iPod shipped on a FedEx truck. It's pretty fast. But there was while I was there was kind of a quantum leap, a step function change in the fundamental sequencing technology. Whereas instead of sequencing just a species, which would take in the order of billions of dollars and about a decade to do, it's a pretty significant investment. You could do an individual genome for hundreds of thousands, tens of thousands of dollars, and do that in about a week. And that is just a complete seismic change in how you look at genomics. The value in genomics is in comparing between individuals and between species. We've never been able to do individuals because it's just too expensive, so we had to look at species. And the idea there is that where you find interesting areas where the genomes are similar, those tend to be conserved through evolution, and as a result, they're biologically interesting. So right away, you get to know what's interesting in the genome and what isn't. And if you do that at species levels, it's good. If you do it at individual levels, you get closer and closer towards the goal of kind of delivering, very personalized care based on your genome, which is just one predictor of many for future diseases potentially. A good predictor in some cases, but just one of many. So we had this new instrument that was designed actually in Cambridge by a company called Solexa. They sent us a free sequencing device that could do an individual genome in about a week. It was very, very early prototype. It had hand-drilled holes in the side of it because it was overheating. When we got it up and running, we put some test DNA in it, and sure enough, a week later, we were getting sequence out of it. So they sent us one more, and then we bought 2 more, and then by about a year later, or maybe not even that, 6 months later, we had a full production facility of dozens of these machines running 24/7, doing more sequencing in a year than in the whole of human history. So terabases of data coming off these things. Now, for an organization and an industry that was used to dealing with gigabytes, we started to have to deal and think in terabytes. The raw data off these instruments They're actually images, 1 megapixel images. They look like star fields. They're very pretty. But we had, tens of millions, billions of these things, in the order of hundreds of terabytes per week that were being generated. And, we're very lucky. We're well funded. We have lots and lots of space inside our data center, and very capable informatics team that could run the infrastructure for us and all those sorts of things. But we couldn't get enough power on site to plug in more storage. The Genome campus in Cambridge is in the grounds of a stately home, and right at the end of an airstrip, which is used for World War II plane flying. And so one of our disaster response recovery scenarios was what happens if a World War II plane overshoots the runway. So it's kind of an unusual situation. But we could not get more power cost effectively into the data center to plug in more storage. And so that was really when we started to really think, okay, well, what are we going to do? Like, where are we going to store this stuff? How are we going to store it? And pretty much everything we tried at that point would fail in some weird and wonderful way, just because we were pushing it right to the edges in terms of the volume of the data and the complexity of the analysis that we were going to run against it. And so that's really when I started to get really switched on to, okay, well, if we're having this problem in the genome field, maybe others have solved it in other ways. And started to look around, and Hadoop was very, very early on back then. It wasn't even version 1 when we were starting to look at it. And I remember I had to convince our IT team. They had a stack of servers literally on the floor in the data center that I just happened to see, and they were being decommissioned. And I convinced them, using my English charm, to just plug them back in and turn them on for me. And we installed Hadoop on, I think it was 5 or 10 servers, something like that. We had installed Hadoop on there and got HDFS up and running, and showed what you could do with more distributed computation and distributed storage. And that's actually what got me interested in cloud computing. I had a friend over in the US, similar background to mine, kind of scientific computing, and we'd known each other for a decade at that point. Gave him a call and was like, "Hey, look, we got this really big data problem. Like, what we got some success with Hadoop. Like, what are we going to do? Like, how do other big technology companies in the US do this?" And he said, "Hey, fly out to Seattle, have dinner with me. I'll tell you all about it." And there's very few people that I would fly halfway around the world to have dinner with, but he's one of them. He's still at AWS. So we were walking to, he hadn't joined at that point. We were walking to dinner, and he said, "Hey, big news. I'm going to join Amazon." I was like, "Okay, why are you joining a bookstore? Like, tell me all about it." And over dinner, he walked me through kind of what would become AWS. So the very early services, the storage services, and what would become EC2, and what back then I think the code name was AWS 157, which turned out to be Elastic MapReduce. Back then we didn't even have code names at AWS; we just used numbers. Then I got a private beta agreement in my email like that same evening, and the next day in my hotel room, somebody from Amazon sent me the very early, it was actually just a jar file, which was the AWS SDK, ostensibly. There was no console back then. It wasn't available. And sure enough, I fired this thing up. I resolved all the class path issues. And an hour later, I'd finally figured out through the documentation was just in an email. I worked my way through it, and I had my first EC2 instance up and running. I SSH'd in, and I was just like, okay, it's like a lightning bolt hit me. It was so obvious to me at that point, a blinding flash of the obvious, that this is how analytics was going to work. This is how applications were going to be built. This is how everyone was going to provision their infrastructure, run their databases. Like, my mind just was overwhelmed with the possibility. And so I got a $300 worth of free service credit from Amazon, very generous even back then, and in return for creating a genomics analysis pipeline in the cloud. And the deal was that they would give me the credits, and I would write a white paper about what we did and how we created it. And I think it's now at least 15, maybe 16 years later, and I still have not written that white paper. So for everybody that put their careers on the line to get me $300 worth of service credits, I apologize. One day, I promise, I will write you the white paper. But that's kind of how I got into it. And then I got a call from Amazon, and 11 interviews later, I was on board and working with the service teams. I actually started as a technology evangelist when I came on board, an early employee for AWS in Europe, and then I've worked in all manner of fields at AWS over the past 12, 15 years or so. So that's how I got into it. It was really through necessity.
Wow, that's an impressive adventure. And I think you're making a good point, because it shows that people who are in the data and analytics space today, they come from totally different backgrounds. So some people like you get started with genome processing and sequencing. So that is different from somebody who gets started from system administration or just processing logs. So and also, yeah.
Go on.
Yeah, I just wanted to mention that it's also interesting and funny that even 10, 11 years ago, we did not have warehouses in the cloud at all. And the technology moved forward so quickly that now the stack that we're dealing with is so advanced, and we're not thinking about the same problems in the same way. Like you mentioned, the cost, the amount of data, and how we're looking at even approaching the problem is totally different.
Yeah, I totally agree. And one of the things I like most about kind of working in this field is exactly that diversity. Like, some folks have really traditional kind of enterprise software background, and they bring their little nuggets of expertise. Some people are really great algorithmic people, or they're like machine learning people, and they bring their perspective. And then you have kind of the different domains that analysis works in. Analysis is a very applied field of kind of computer science. Like, you do analysis not for the sake of it, but to answer very specific questions inside your organization. And so getting to work with folks from still get to work with folks in life sciences and healthcare, but looking at folks, what they're doing in terms of modeling in financial services, or learning a ton about sports analytics has been really, really exciting. We do a lot of work with the National Football League, and my background isn't exactly in American football. Based growing up in England, I'm much more of a soccer guy, but learning from them about what it takes to predict a route or do pass completion probabilities, and how do you do that with enough accuracy that it's useful, and with enough latency that you can pipe it directly into the production systems at the NFL so that it can get inside the broadcast. And then there's all the machinery around that of just the human. How do you make it exciting? Like, how do you train the commentators on how to talk about it? So there's data analytics is incredibly applied, and it's almost always kind of 50% technology, but then kind of 50% the cultural, organizational pieces, which are fascinating as well.
Absolutely. Which actually brings another good point, that I think today, if we look at data and analytics in 2022, I feel like there are two different directions where we're going. So the first one is analytics of an actual domain and business use case. So actually solving a business problem and building pipelines to process data and bring actionable outcomes from solving a problem. But then there is this operational side of things, where sometimes you don't even have to know about the business problem, and you're working on the intrinsic aspects of the system. Maybe you're building the self-service environment that other engineers can use to actually solve a problem. So I'm very curious what our audience thinks of, like, what is data and analytics today? And I wanted to ask you, Matt, like, what components do you see forming the definition of data and analytics today?
Wow. Yeah. How long have you got? I think I don't think there's any. I don't think there has to be. I'll give you my perspective for sure, but I don't think there has to be like a single answer. What the other really interesting thing about analytics, I was talking to the team about this the other day, is analytics is really messy. It's often where inside an organization, it's often where kind of the rubber meets the road. If you imagine you've got traditional applications, and they're running against a transactional database, or they're running against DynamoDB, or whatever it happens to be, but they're viewed item by item, transaction by transaction, page load by page load, which is great. But analytics, you almost always want to take a longitudinal view across all of that. And as a result, some of that data is organized functionally. You know kind of how it relates to each other, and you understand the function and the knowledge. It's kind of implied in the schema and where it's stored and all the rest of it. Sometimes it's just logically stored. It just happens to end up in a open search cluster, just happens to end up in a data warehouse. So, analytics is just kind of inherently messy because of the way the data is collected. And analytics is where all of that messiness kind of gets wrung out. So you can actually start to actually ask questions of the data. But, if you take the applications which actually often generate the data, or the IoT systems, or whatever they happen to be as kind of the data sources, I think the next piece that most people would look at would be, a data warehouse. And that's usually where, if you've got data which, even if it's from multiple sources, which fits inside a common schema, you're kind of going from structured data, even if it's in multiple different databases, but following the same schema, you're going from structured data into structured data in the data warehouse. Like that's a very natural fit, very easy to do. You don't have to do a whole bunch of, transformations in order to be able to get it there. And then you have this big complete view inside your data warehouse. So you do that all day long. That's great. Where some of the less structured data, or data which is structured but doesn't share a schema, often ends up in a kind of landing zone, which gets translated and transformed into a data lake. That's really a case where you want to be able to take that data, transform it into an analytical format like Parquet, or various other modern forms as we were talking about earlier, Iceberg, and then use that, often stored in S.2, to run queries against it. And then customers often want to be able to run queries across data in both their data lake and their data warehouse. Many customers on AWS use Athena for that. So then you've got data lake, you've got data warehouse. Data integration is probably the third piece. So using services like Glue to do all that data engineering pieces. And then the search for log information. And then the other end of the end-to-end spectrum is where you actually get some usage out of it. That's commonly done with business intelligence, so things like QuickSight, or increasingly put into a machine learning pipeline inside SageMaker or something like that. So those are kind of like the major components as I see them, like warehousing, data lake, integration, search, business intelligence, and then machine learning. But I'd say it's messy, and I think if you asked 100 data nerds, you'd get at least 100 answers, probably more.
I think you're right. Another aspect may be data governance, which might be a part of what you already mentioned, but I feel like we're moving more and more towards bigger focus on data quality and data governance, and we're going to have some sessions about it today, where previously the struggle was that we had too much data, and now we have too much data, but we also don't really know how to get valuable and insightful, high-quality data from that vast, storage that we already have.
I think you can never have too much data. You can never have too much data. Like there's almost always signal, and in the cloud you can store as much as you want. So I'd encourage everyone to do it. But you're absolutely right. You want to have the first thing that many customers set up before they get into all the technical pieces is a very robust view into governance. And there's kind of a view that you can kind of look at governance as kind of a lockdown, almost like a data prison, where you got your data and it's like really well controlled, who can access it. And like for certain types of data inside your organization, like PII information or credit card information or whatever it is, or information which is heavily regulated, you do want to have those controls. But what we see from customers is, as you start to think through your governance, that slice of very controlled data is probably pretty thin, maybe 20% of your entire data estate. And the 80% of the data that's left, you still want to govern. We want to understand the quality. You want to understand who's using it. You want to understand the lineage. You want to be able to provide access controls and all the rest of it. But actually driving invention and innovation through that data by making it available easily to like large swaths of your internal builders, there's a huge amount of value there. And so finding that balance of correctly securing the data that is sensitive, whilst also providing easy access with the right governance controls, so that you can just build wonderful things, without the permission necessarily of anyone, telling you to go do it. That means the builders just have a lot of creative freedom, and a lot of opportunity to take that data, combine it with other data, and then build applications around the result, and potentially even publish it as internally as what a lot of people call a data product. So we see a lot of organizations that think of data much more like a software product, much less like just amorphous blob inside like a random silo somewhere, but more like a very highly polished kind of gem that has real value, that they take the time to, they'll have product managers that work on it, and they'll have an engineering team that is focused on that data set, and they'll be fixated on quality and timeliness, and they'll evangelize internally what you can do with it and all those sorts of things, just like you would with a kind of service-oriented architecture with traditional software.
Absolutely. I think that's really important because, like you mentioned, there is a kind of a shift where we see the conversation moving from just data governance to data observability, from a centralized data architecture using a data lake or data warehouse to a decentralized microservice-like architecture with a data mesh, which is still a really new concept that has a lot of information online, companies trying to implement it and trying to understand it. So I was curious if you have any thoughts on this new paradigm shift of data mesh and the socio-technical systems that could benefit from that new thing.
Yeah, sure. Absolutely. I think it's very early days for meshes and data architecture in general, but a mesh is actually a pretty good way of solving some of the messiness that I was talking about, whilst also providing teams with the agility and speed to actually work with the data products. So the general idea, if you're not familiar, is that you have a series of consumers and producers, effectively. So you have systems which will consume data from various different sources, and many of those systems will also produce data, which can also be consumed by other systems. And so as a result, you have this sort of growing graph of nodes and edges, which kind of interoperate all of that data. Now, in order to make that work really well, a predicate is like a great governance approach. So really thinking through, how are you going to monitor lineage? Like if you pick a point on that graph, you should be able to answer like what data flows into it, from upstream, downstream, and what data it is flowing, or what systems it is flowing into upstream. And so and who is using that data for what purposes. And so having a robust governance approach is really, really important. But if you get that right, then you get a tremendous amount of invention as a result, because folks inside your organization can usually go to a centralized catalog. They can see the business terminology and the business trends and the knowledge which is stored inside those data sets. They're usually highly curated, highly polished. When it was last updated, who owns it through the catalog. And then often with just a single click, you can jump in and request access, and the owner can auto approve if they wish, or they can take a look at your request and they can approve it, and then you can go for it. And then you can start loading it, querying it in Athena, or running Spark jobs against it, whatever you want to do. Usually with the purpose of driving some incremental value to that data. So maybe you're combining it with another source. Maybe you're doing feature engineering for machine learning. But like the ability to be able to take that data and like add value to it is incredibly powerful and very compelling for a lot of organizations that want to take that approach. So there's actually nothing wrong for what it's worth of having like a more centralized data lake. A lot of organizations start there. Data lakes can even become kind of the source of record inside a lot of organizations for where the single source of truth is for reporting and for even financials, things like that. So there's nothing wrong with that. And honestly, if you talk to a CISO and say, hey, we're going to have this mesh and everyone can just do what they want, like the CISO usually just freaks out and tries to shut the whole thing down. So you do need to do it thoughtfully, and you do need to have a really good understanding of, where your sensitive data is. You have to have a really good sense of what type of data you're working with, and what teams want to access it. And so can't really be fast and loose with it. Just like you wouldn't be with building software in general, because you want to be able to have best practices effectively of software development and software engineering, and you want to have environments and tests, and you want to be able to have source control, and you want to do pair programming, and all those sorts of things that we've learned over the past 50 years of building software that really work, increase the quality. We're still figuring out what some of those are for data products, and governance and understanding lineage and understanding quality and freshness and who's doing what and all the rest of it. That's really, really important. So you can't go fast and loose. There's some emerging best practices which will give most organizations just a tremendous accelerating effect of using their data for some really cool things.
I think you mentioned a really important thing, that you should not just jump on a new paradigm because it's something that everybody's looking at. And like you said, centralized systems are okay and they work for vast majority of scenarios and use cases. When you're running into bottlenecks and when you are running into problems, then it's time to kind of discover what can be the gradual thing to improve and how to get buy-in from the broader organization. And I think another interesting aspect is the cultural shift, where we're looking at a different balance in terms of engineering and data engineering teams and how they're structured, where we can see a mix of subject matter experts joining these data product teams and kind of building data products as a service and offering, kind of thinking in advance what kind of functionality would the consumers need and what they can offer. I think we're definitely moving in this innovative direction, and it's definitely a space to watch, but not to kind of jump on immediately.
I agree, and getting a lot of that working is actually as hard as the technology in some cases. There's spinning up a new Redshift data warehouse. You can do that with a serverless, in a serverless mode where you don't have to worry about operations, and it's up and running in a couple of minutes. You start loading your data, you run your queries, you connect it to your dashboard. You can get that up and running, pretty quickly, hours if not days, right? But what you talk about, the how you're actually effective with analytics, because it is an applied science. You really do need like a good combination of those technical folks and the domain experts. And anyone that's worked in any sort of technology project knows that there's in this sort of a natural repulsive force against technologists who are trying to just implement what's going on. And sometimes the domain experts, it's not like they don't get on personally, but they often don't speak the same language and they don't understand the same challenges in the same way. And so there's this kind of repulsive force against them. And that repulsive force is often stronger if the domain is more complicated, which is often where the opportunity is for machine learning and analytics, or the technology is complex. And so when you've got something like deep neural networks, or you've got something like reinforcement learning, or you've got like just very, very complicated statistical models inside your analytics world, that repulsive force can be very, very strong, and it can push your domain teams that you need to work together further and further apart. I think what at least we found, working with customers and certainly here at Amazon is, the faster the technical teams can move, and the more agile they are to responding to the domain experts' requests and understanding and all the rest of it, actually the weaker that repulsive force is, the more it almost becomes an attractive force, because you can just move and iterate a lot more quickly, and you can respond and you can go back and forth, and you can get a really good dialogue going with your business partners or your domain experts. And that brings those two groups much, much closer together, even for challenging problems and very significant technology challenges, which is super important. So you have to have, as an organization, you kind of have to find the right operating mode where those two teams can interact really, really smoothly. And part of that is having technology which can move very, very quickly, just because you're solving a simpler problem. You're not trying to do two things at once, and it shifts the focus on problem solving much more into the domain. And you stop becoming the team that says, no, we can't do that because we haven't got X, we haven't got enough storage, we don't have enough compute, we don't have the right, we don't have the data formatted that way, it's not clean enough, all those sorts of things. You go from being that group, which frustrates the hell out of anybody, right? And particularly domain experts that just want to understand what they can ask, to where you can say, yes, give us a couple of hours, we'll have it done for you. This is what then we'll be able to answer that question. And it really enables, the domain experts and the technical experts to collaborate much more closely. And meshes, have a role to play in that as well.
So I do have a last question for you, but before I ask you, I wanted to ask our audience, what are some of your pain points when working with data and analytics? Because Matt is indeed a vice president of business analytics, so he has some influence to the products that you are using. So there is a pretty high chance that your feedback would be seen by service teams, engineering teams, and product teams. So feel free to put your thoughts in the chat. And my last question to you, Matt, is what is your advice to those engineers who are starting in the space of data and analytics today?
Yeah, I think my advice would be to really approach both the technical and the sort of humane cultural elements of your job with the same vigor and the same discipline. Analytics is super applied. I'll say it till the end of time. And to be successful, you need to actually deliver on something. And so, really thinking through as someone who's new to this space, really being candid with yourself and your teams around, what is our level of data readiness? Like, what do we have today that we could actually do something with? Where's the bright, highly polished jewels in our crown that we could actually do something with? Where are we less ready? Where, if we look around the corner, 6-9 months from now, what data are we pretty sure we're going to wish we had started on sooner? And like kind of asking those types of questions, like really set you up, for success, kind of by looking around the corner. And the next thing is like really understanding the business domain and really understanding where the business priorities are for the analysis. Like, what is important? What will be a real needle mover for the organization? Like, do you want to drive a 1% increase in forecasting accuracy? Like, is it super important that the personalization engine is well fueled and well oiled and working really, really well? Do you need like a wealth of dashboards because you don't have any reporting in place? Like, really understanding what's going to help the business, that can really help with prioritization. And then finally, just be candid with yourself about what you and your team's level of expertise is, and then work with your teams to build that over time. Like, this is a discipline where learning is going to be a lifelong pursuit, and you kind of have to be on board with that. Like, things are moving really quickly. There's new models and data sets from industry and academia virtually every week. And so being mindful that you're going to need to keep learning to stay relevant and connected with that literature and the latest open source projects, whatever they might be, super important. And so then if you've got those three things, like you've got a good sense of data readiness, you've got a good sense of business priority, you've got a good sense of kind of the X factor, what can you actually execute on, then you can actually engage with a very, very broad set of partners inside your organization and prioritize in those three dimensions. Like, look, we have this data. Like, we have these data problems, these business problems that we want to go tackle. And if you've got high confidence in just 2 out of 3 of those dimensions, like you'll be wildly successful. By the way, if you've got 3 out of 3, you do those all day long, you're gonna do great. If you only need 2 out of 3 of those to be successful, and if you only have 1 out of 3 or 0 out of 3, then you got a bit of work to do in order to build those 2 of those 3 things up. But I would focus on that. I think that's a mental model which has worked for me and for many others inside the company.
Excellent. Thank you so much for this wonderful conversation. And I think I'm going to transfer it over to Darko and Danny, our dad joke experts. So thank you so much, Matt. It was nice chatting, and see you later.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.